Okay, so we're going to do measures of variability today. This is recording attempt number 3 now, so we might do a little bit quicker version of this. The sound is not working, so hopefully it is right now. So here's the thing. What we're doing is we're talking about, instead of like the middle of the data, like measures of central tendency, we're looking at how spread out the data values are. So it's really helpful to be able to look at things like that. I'll give you an example. So say I want to see how my students do in a test. If I can calculate something called the range, and we've talked about this before, the biggest minus the smallest, that really tells me how stretched out or how spread out my students are. So for example, if the range is really large, I know I have people kind of all over the place. So really great scores, really low scores. If the range is really small, I know that everybody's doing about the same. Now, whether that's good or bad, we don't know unless we know where the range is. But it means they're all about in the same boat. So I know what I need to do as far as either moving on or being able to do what I need to do some maybe help and remediation for that. A great visual tool to be able to show how spread out things are, though, if we just know the range like the biggest and the smallest, well, that's good information, but we don't really know what's happening in between. A box and whisker plot is a way to show that variation in a much more visual way to see how stretched out everything is. So we have basically 5 main things we need for a box and whisker: the minimum value in your data set, the maximum, the median, the middle score, and then the quartiles, Q1 and Q3, kind of the median of the top half and the median of the bottom half, being able to know where those quarters are. So we're basically break the data into 4 equal sized chunks. When we do that, though, we have to be aware of outliers, right? So we have to be talking about, okay, where are these values that are either much bigger or much smaller located? And today we'll talk about mathematically how you actually calculate that. There is actually a way to do that. So I gave you a picture here just so you can have a basic idea of how you make this box and whisker plot, or box plot as some people do that. It's on a number line. That's really important to realize. It's smallest to biggest, regular intervals. We're trying to see how this data lays out, so it's really important that you go up by the same amount each time. We draw a box to show the IQR, this interquartile range, the length of the box. That's a really important calculation we're going to be using. And then we put that line through to show where the median is in each of those. So we have the min, the first quartile, median, third quartile, and maximum. One thing to be aware of then is that each of these sections and segments represent 25% of the data set. So that's what a box and whisker really does, is all of these represent the same amount of data. They're all 25%, but it's a way to show how stretched out they are. So if they're about the same length, you know you have about the same variability. If one's really long and one's really short, we know one's really varied and one is not varied at all. One thing to keep in mind too, the outliers. If you do have outliers in your data set, they are not connected to the whisker. So if I wanted to show an outlier on this data set, I would just have a dot. Or you could have more than one outlier. You might have a couple of them. They're not connected to the box, so they can be either above or below, and you can have multiple of them, but that's what you would be doing with outliers. Okay, so I know you've done some of this before. So interquartile range, that's the length of the box that we just talked about. That's the Q3 minus the Q1. So think about what the words mean. The range is the smallest minus the biggest, or the biggest minus the smallest. How spread out are they? Interquartile means between the quarters. So between quarter 3 and quarter 1, how long is that? We use that to help us calculate the outliers. Now, there's something called the semi-interquartile range. Your book talks about it, semi meaning half. There's no really statistical value in dealing with that, but I just wanted you to be familiar with the term. It would just be half of whatever that number is. Okay, let's talk about outliers. Outliers are those very large or very small values. To calculate an outlier, it's 1.5 times the IQR above Q3 or below Q1. Meaning, if it's more than that value above Q3 or less than that value below Q1, it's considered to be an outlier. So that would be Q3 plus 1.5 times the IQR, and then Q1 minus 1.5 times the IQR. So there's actually that mathematical computation we can do to do that. So let's try this and see if we can get a value on here that we can do. So we have this list of entrance test scores. These would be like SAT scores, not ACT scores, because SAT is out of 1600 where ACT is out of 36. And it's their values. And what I want you to do is see how spread out these kids are on their test scores. So a great visual way to do that is by doing a box and whisker. So what we're going to do is we're going to go ahead and put these in order, and then we are going to kind of do our sorting and organizing here so we can figure out those values that we need. So go ahead and reorganize your data values here. So we're going to put them in order, smallest to biggest, so we get all of our numbers in the right order here for organizing purposes. And then we can talk about max, mid, and median, and then the quartiles. And I think we are good to go here. Okay, so let's make our list of important pieces of information. The minimum value in my data set is 490. I'll leave a spot for my Q1 here. The median. Okay, so the median, the middle, there's 10 values in my data set. How do I know that? Well, it tells me. Other you can count them, so we could count to 10. So I need to take the middle of these two middle values. So my median is going to be right here. So in order to calculate that, I would do 599 plus 600 divided by 2. Remember, if there's not a true middle, we need to calculate that. All right, and then Q3, I'll leave a spot for that. And then my maximum value looks like it's a 740. Okay, so in order to get the Q's, we need the middle of the top and the middle of the bottom. So let's look at the bottom half of the data. So here's my dividing here. So in this bottom half of the data, Q1 is the middle of that bottom half. It's where the first quarter of the data would stop, which would be at 560. And then the Q3 would be the middle of the top, which would be at 620. So we need to be able to figure out where those middles are. So think of it like the median of the top and the bottom. Okay, let's talk outliers. Do we have any outliers in this data set? Well, we need to calculate the IQR first, all right, which would be the length of the box, so Q3 minus Q1, so 620 minus 560, which would be 60. And then we take 1.5 times the IQR, so that would be 1.5 times 60, which would be 90. All right, so now if we're going to figure out an outlier, then we have to take and see, is there a value or values that are more than 90 above Q3? So that would be 620 plus 90. So that's 710. Well, is there a value in the data set bigger than 710? Well, sure there is, 740. So this one would be an outlier for sure. How about the next one down, 680? Nope, that's smaller than 710, not an outlier. Okay, on the other end, I do Q1 minus 90. So 560 minus 90, which puts us at 470. Okay, is there a value in my data set below 470? Well, no, the smallest value in our data set is 490. No outliers on the bottom then. That's what that would tell us. Okay, so now let's talk scale here. I need to be able to figure out something to do for this interval on my number line. So I need to, I think about the range. What is the max minus the min here, so I know what I'm dealing with. So my maximum value is 740, my minimum's 490. That's 250. That's a pretty big range of values. So if you think about going by even tens, you would need 25 intervals. Well, I don't have nearly that many. If I went by 25s, I'd only need 10, and that's a lot more reasonable. Now, do you really want to start at 490? Do you want 490 to be your first interval if you're going to go by 25s? Probably not. If you're going by 10s, it wouldn't be bad at all, but by 25s, not so great. So let's see what's close to 490 that might be easier. Well, you could do 500, but that's bigger, and so that means your data value would be kind of off your graph. I think we almost need to back up one interval and go back to 475. So there's no really right or wrong way of doing this. You just have to make sure that you're going up by regular intervals and that you can represent all of your data values easily on the spread that you have. So you don't want to have to do so many tick marks that it's ridiculous, and you don't want to have too few so you can't tell what's going on. And I think I have to just add one then. Okay, so when we do our box and whisker then, our minimum value happens at 490. And then our Q1 is at 560, and that is not an outlier, so I'll connect it. My median's at 599.5. My Q3 is at 620, so I can go ahead and make my box. Now, I know that 740, that maximum value, is an outlier. That means it can't be connected. So what I have to do is figure out where the end of the whisker is going to be. It'll be the next smaller data values. The next one down is 680. That wasn't an outlier. So that's going to be where that whisker is connected. So it gives me a really good spread of what that variability is going to look like. And again, to be able to see these 25%, the least varied part of my data set is right here. That's 25% of my data, and it's the smallest. It looks like the most varied would be from Q3 up to the maximum, that outlier. That's the most spread out. So I can say something about these test scores. Those people on top are really spread out. Most people, or the least varied part of the data, would be in that 600 to 625 score. Okay, so I want to show you a couple things on your graphing calculator. If you can go into your stat menu, into edit, and go ahead and put your data in list 1. So it can just be in the order that I gave it to you. It doesn't have to be organized. So put your data in list 1. So go ahead, pause the video, do that. Then we're going to go back to stat and over to calculate. And I want you to do this one variable stat set number 1. We only have one variable because we put it into this list 1. And is this what we want to do? Yep. And go ahead and press enter. Wonderful. Gives you a bunch of information. Let's talk about it. Top one, the X with the bar over the top. So this very top line right here, that is your average. It's actually called X bar. That's statistically what you would call it with the bar over the top. That's your average. That's like adding them all up, dividing by how many values you have. Wonderful time saver for you. You can use that as much as you need to. On the next few lines, we're going to skip for right now. I want to go down to that n equals 10. What does that mean? How many values are in your data set? 10 of them. So you don't even have to count how many values. It will do that for you. That arrow means there's more stuff to see. So let's see. We have, ooh, look at the minimum value in our data set. Awesome. Q1, the median, which we calculated, Q3, and the max. Everything you need to know about this data set to make a box and whisker and look at variability right in your stat calculate menu. It's fabulous. Okay, now I need you to go to your stat plot menu. I want you just to have plot number 1 turned on. So if anything else is on, turn it off. But I just want you to turn plot 1 on, and I want you to select the box and whisker. Now there's 2 different options. One of them shows outliers and one doesn't. So I want to go to the one that shows outliers, which is that first one, the one that I have highlighted. Are your X's in list 1? Sure they are. If you ever need to change that, you can. They're above numbers 1, 2, and 3. You can change those list names, but that's where mine is, so I'm going to keep it there. Now go ahead and hit graph. When you do that, you may not see anything. And so think about why you might not be able to see the graph on your screen. Think about what your window might be. Usually we're graphing like -10 to 10, or like the last time I graphed, it was like 50 to 90. There's no way I'm going to see a 750 on that graph. So I need to make sure I update my window. So I'm going to use the exact same window as what we did for our number line. So 475 up to 750 going by 25s. For my Y scale, I just start at 0. You can go up to whatever you want. It really doesn't matter because we don't really have Y being recorded. So it's still going to show you the same graph no matter what. So you can kind of play with that. But the thing you need to adjust is your X's so you can see what those intervals are. And then go ahead into graph. And here we have the box and whisker that we made by hand. It's a great representation. Even cooler though, you guys, go to the trace button. It will actually, if you arrow through, tell you all of those values that we got in the stat calculate menu, the median, the Q3, where that whisker stops, and then the maximum. It's wonderful. So we have that great ability to be able to tell those values right from the graph. It's a great tool. So please utilize that, stat calculate. Okay, so I want you to try this with one set of data on your own. So if you want to go ahead, please, and just enter in your information into your graphing calculator. So go ahead and do that, and then we can get our list. So pause the video so you can do that. So what you should have gotten, your minimum was 47, Q1 is 50, the median is 53.5, the Q3 is 59, and then the X max, or the top value in the data set, was 62. Gives us a kind of a good read on what we've got going on. Let's talk outliers then, see if this data set has outliers. Sometimes it's kind of nice to think just gut check if you think there really looks like there are. This one looks like they're pretty close together, but let's see. We'll do our IQR first. So that's third quartile minus the first quartile, which would be 59 minus 50, so it's 9. Then we need to calculate 1.5 times the IQR, which would be 1.5 times 9, so 13.5. So if we have any data values that are more than 13.5 above Q3, then it would be an outlier. So that would be 59 plus 13.5. So that would be 72.5. Well, do we have any values in our data set bigger than 72.5? Well, no. X max is 62. No outliers on top. Or if we have any values that are less than 13.5 below Q1, so 50 minus 13.5, that would be 36.5. Do you have any values in your data set smaller than 36.5? Well, no, the smallest one's 47. We're good. There are no outliers in this data set. So we have to think about that, though. We need to know if they're connected. All right, let's talk about scale. I'm going to do the range of my data set here so we can talk about what our intervals should be. So 62 minus 47, we have a range of 15. I could almost go by ones. I really could, but I don't have quite enough tick marks. I need 15 of them. So I'm going to go by twos, I think. And I could start at 47 and go by twos, but a lot of people like even values. So if I want 47, I guess maybe I'll start with 46. Again, there's no wrong way to do this other than you have to make sure that your intervals are always going up by the same amount each time. They have to be regular intervals. That means regular always means the same amount. All right, so we'll do our box and whisker here. So we have 47 for our min. Q1 is at 50, no outlier, so it's connected. 53.5 is our median. And our Q3 is 59. So we have our box. And then our maximum is a 62. And in this case, the whiskers are actually both the same length. So they're equally varied. The most varied part of our data set here looks like this third quarter where we have from the median up. That's the most stretched out, the most varied part of that data set. All right, so we have a really good read on how to show visually what variability looks like in a graph with a box and whisker plot.